Hi, this is Ravi Ozarkar and welcome to the video number 11, which talks about adding AIC test loads for the AIC 2021 Student Steel Bridge Competition. Okay, we're going to use GT-STRUDL to add these test loads. Now, in the previous video, video 10, we looked at how to review the results. Okay, we looked at behavior of the structure due to just the self weight. Click on File, Generate GT-STRUDL Text Input File, and click on Generate Input File. Here I'm going to call that chapter number 11, okay, where we just ran the analysis on the structure. So if you look at this file, if I double click on it, it has all the commands in it, including the self weight command that we gave. Okay, now so what we're going to do now is add a lateral load of 0.0345 kips along the global z direction. You know, I'm on page number 120 of the PDF document, or chapter number 13 on Kindle or Amazon. Okay, so if you have downloaded the book, first what we need to do is create a new load case. If you click on Create button, Loads, and then activate independent loads. Here I'm just going to create a new load case and call it load case number 2, and the description is going to be lateral load. Okay, so this is the load that the AIC competition judges will add to the bridge to see if it has enough lateral stiffness. Okay, so if you go to Store New, now you can add those joint loads. The goal here is to find out how much deflection you're going to get. Okay, so we're going to set that force value. The force value is, there's going to be like a load applied along the y direction, which is a point load, and then there's also going to be a load applied along the global z direction to do a lateral load test. Okay, so here I'm just going to go in and apply a member load. Okay, and then that member load is going to be along the y direction, and it's going to be a uniform load. Okay, and that load is going to be negative 0.0341. Okay, it's not a point load, as I said, but it's actually UDL, okay, on some of these members, and your member needs to be designed for that type of loading. Okay, now note that the hit option is on, so I can actually click on any member that I like in the graphics and have that load applied. Now that magnitude might not be okay because the length of the member is actually different from what we have in the book. Okay, so it's not going to produce the same effects. Okay, but that's fine. This is just an example that I wanted to show you. So what we can do now is click on Add Member Load. Okay, and let's just add it to this member. And if I right click on it, it actually shows you that load in the STRUDL graphics. Okay, next thing that we want to do is also add a load along the z direction, which is a concentrated load type in this case now. So I'm just going to say joint load. The direction is going to be FZ, and the value that I'm going to put in is actually, let's put in a member load. Okay, and it's going to be a concentrated load type, a force along the global z direction, and it's a concentrated load. And what I'm going to do is apply that with the magnitude of 0.0341. So that's okay. I'm going to remove this negative sign. And the location where I'm going to apply it is at half of the length of the member, which is 0.5. So once we're done with these inputs, I can just click on Add Member Load button and select the member to which that load needs to be applied, and right click, and you see that load applied in the graphics. Okay, now if you make a mistake, no problem, you can go in and create loads using GTStrudel grid sheet if you like, and edit those values if you want. Okay, uh, once that's done, that takes care of the lateral load case definition. Now we need to create a new load case. Okay, and we're going to say, okay, the new load case is going to be called, this is page number 124, step number 18. Load case is going to be 3. Description is going to be vertical load. Okay, if you click on store new, that vertical load needs to be applied with a force value. Again, it's going to be a member load. If in the y direction, it's a UDL. Okay, and that needs to be applied with the value of negative 0.0682, and the start location is going to be let's say 0 to end location is going to be 1. Okay, so the whole member is going to take that load. Okay, and then we're going to apply it to 2 members, to 4 members actually. Okay, so if you say add member, you can click on the members that actually take these loadings. Okay, so you have to be a bit careful when you click on these beams, because it's in 3D graphics. You can actually take advantage of the views if it becomes too complex. Okay, and now if you right click in the graphics, you can actually see that UDL applied to those members that I just selected. Okay, using the right click. Okay, so we have created our loads now, load cases. We need to create some load combinations. So page number 126 of the PDF document talks about how to create load combinations. Okay, so if you go to create loads, there's an option here called define dependent loading combination. Okay, or you can just go and form a load. Okay, this one is okay for linear static analysis. This one is okay for both linear static and non-linear analysis. Okay, so I'm going to go in and create define loading combinations like the book says. First task is to enter the load number. Okay, so the load combination number is going to be 101, and what we want to do for this one is say this one is actually a combination of self weight and lateral load. Okay, so I'm just going to take that title, copy it, okay, for future. So it's self weight plus lateral load, and I'm going to store that new load case. Okay, a load combination. Now that load combination apply it can be seen now under define dependent load cases. Okay, so I can go in and select self weight and lateral load, and say, okay, I want to apply a factor of 1, add those components to that dependent load case, and we've created a load combination. Okay, the second load combination that I want to create is a lateral plus self weight. Okay, so I'm going to call it load case 102, and this one is actually going to be a vertical plus self weight. Okay, and I'm going to say store, and this one I'm just going to say I want self weight and vertical load applied with a factor of 1, add component. So there is our load combinations in this dialog box. Okay, once that's done, I can click on the done button to close that dialog box. And once that's done, we can now run a linear static analysis on the structure. Okay, so step number 35, page 128, tells you to go to analyze, linear stiffness analysis standard. I'm going to say yes, and it runs the analysis on the on the structure again. Okay, now we have more load combinations here and load cases. Okay, so we looked at how to create loads and load combinations in this exercise. In the next chapter, I'm going to show you how you can leverage the STRUDL language to make changes to your model very quickly.